All right, we're going to expand a couple of binomials, and let's first look at the number of terms that are in a given expansion. For example, number 11, the original exponent is a 6. You'll notice the number of terms in the expansion is always going to be one more than the original exponent. So if we look up at the top here, x plus y to the 5th, 1, 2, 3, 4, 5, 6. One more than the original exponent. So let's look at number 11. The blanks are already given to you, 7 terms. And what I like to do is first set the problem up using the triangle from up here. So we need to figure out first which row of the triangle to use. So since the exponent is a 6, we're going to look for, I'm going to call the exponent n. In this triangle, the first row is n equals 0, the second row is n equals 1, and so on. So let's find the row that corresponds with n equal to 6. All right, so n equals 6. These are going to be the coefficients of the terms in my expansion. So I'm going to go ahead and start by just writing all the coefficients in. So down here we have a 1, 6, 15, 20, 15, 6, and 1. I'm going to secondly put some parentheses in to show the 2 terms that are in the binomial. So I'm going to put 2 parentheses in for every term because I know that we're going to have both of these terms in our expansion. All right, the first parentheses in every term is going to be the first term in the binomial. So the x is the first term. I'm going to fill that into all of my parentheses. The second parenthesis is going to be the second term in the binomial. So in this case, it's y. I'm going to fill that in to all of my parentheses. The last thing we need to do now is fill in the exponents for both the x and the y's in all of our terms. So we know that for the first term, in this case it's an x, the exponent is going to decrease from the original exponent to 0. So we're going to start with the original exponent, which is a 6. And for the x's, I'm going to decrease that 6, 5, 4, 3, 2, 1, all the way to 0 for the last term. And then we know for the second term in our expansion, so if we look up here, the second term, in this case it's a y, the exponent needs to increase from 0 all the way up to the original exponent. So I'm going to start with 0 and keep increasing it, 1, 2, 3, 4, 5, up to 6, which is the original exponent. The last thing you need to look for is to see if there's anything we can simplify further. We know everything to the 0 power should just equal to 1. So let's simplify this. We have 1x to the 6th, this is equal to 1, plus 6x to the 5th, y, plus 15x to the 4th, y squared, plus 20x cubed, y cubed. And notice you don't need the parentheses anymore, so I'm just going to leave those out. X to the 1 is just x, x to the 0 is 1, and so this would be the final simplified expansion. So let's look at how this one is slightly different than number 14, for example. Now, we don't just always have x and y as our terms. These terms can be anything. So in this problem, what used to be x is now 2x. What used to be y is now 1. So I'm going to do the same process I did up here. It's to the 5th, so there's 1, 2, 3, 4, 5, 6 terms, one more than the original exponent. So let's start by filling in our coefficients by looking for the row n equals 5 in our triangle. So now we're on this row right here. So I'm going to fill these exponents in first. 1, 5, 10, 10, 5, and 1. And then let's put 2 sets of parentheses next to each term for the 2 terms that we're going to fill in. Now in this problem you're going to see the value of putting parentheses in because now the term we're going to fill into the first parentheses is 2x. If we didn't have the parentheses in there, then when we put our exponent in, we wouldn't know that the entire thing is being raised to the exponent. The second term in this problem is a 1, so let's put the 1 into all the parentheses that are left. And now all we have to do is fill our exponents in. So again, the first term exponent is going to start at the original exponent and decrease, so 5, 4, 3, 2, 1, 0. And the second term's exponent is going to start at 0 and increase all the way to the original exponent of 5. Now let's simplify what we have here. Be careful when you have this quantity to the 5th, you have to raise 2 to the 5th and x to the 5th. So this is going to be 32 x to the 5th. 1 to the 0 is just equal to 1. Here we have 5 times 2 to the 4th, so that's 5 times 16, which is 80 x to the 4th. 1 to the 1 is just equal to 1. Plus, here we have 2 cubed, which is 8. 8 times 10 is 80, and then we have x cubed. 1 squared is equal to 1. Here we have 2 squared, which is 4. 4 times 10 is 40. X squared, 1 cubed is 1. 2 to the first power is 2 times 5 is 10. X to the first power, 1 to the 4th is 1. Lastly, we have this to the 0 is 1. 1 to the 5th is 1. So this is just equal to 1. So we've expanded it and simplified it, and so that's your final answer.